ask us to be able to define or identify the standard deviation of that particular data set. Standard deviation is about as simple as it can be. It's as simple as finding a mean. Go to the stats menu, open a list of data. If you don't want the data that's there, clean it out and put in the new data that you want. The calculator does not care if the data is arranged sequentially. It does it in any kind of a hodgepodge order. Check the data for accuracy because there's no forgiving hands out here. If you type something in wrong, the calculator's trusted that you've done it right. Check your data because one of the biggest mistakes is that you have a data value wrong, and that will distort your mean, it will distort your standard deviation, and it will definitely distort everything you do with normal distributions, which is upcoming. And then run one variable statistics. So in this particular case, if I pull up the calculator, let me shrink that down just a little bit because I want you to be able to see all the calculator, okay? Then remind me what you know about the calculator. After we turn the calculator on, how do we get to the statistics menu? Stat key. What do we do in the statistics menu? We edit, which is option number 1. If there is data that is in the calculator already, do you still need that data? Maybe yes, maybe no. If you're working on a problem and had some difficulty with it, and you wanted to ask about it in class, you probably wouldn't erase that data set because you know you're going to have to put it back in again to fix your error when you get the answer to your question. So where do you put the data is up to you. And again, you got 6 lists of data that are sitting out there. This is not the data that I currently have, so refresh my memory about how you can get rid of data. Okay, I have different opinions already. I heard those things. One opinion is to start deleting them one at a time. How long could this take you? Because each list is up to 999 lines long, and if you've got a small data set, that's efficient, but if you've got a large data set, you can be there for a while. Second method, move up to the cursor, press the clear key, not the delete key, and then press either the enter key or one of the arrow keys that are sitting over here. Do not use the delete key while you're in the labels up there. It removes the whole list. Then you got to run setup editor. And now, pretty simple, type. It's not that difficult, and you'll spend more time typing on the next test that we come up with than you will actually picking up your pencil and doing arithmetic work by hand. I put in 12 pieces of information. That's how many are up there. I scroll back to make sure I haven't done something intelligence challenged with my big fat fingers, and I got the data that's correct in the problem. And now, stat, calculate, and remember we have a couple of different screens that we might see here. Those of you that have the newer models of the 84 are going to see a screen that asks for your X list, asks for the frequency list, and then tells you to calculate. So just to remind you again, X list is your responsibility if you have that menu-driven screen to tell the calculator where to look. It will not let you move off of this screen until you put a value in that screen. So that could be list 1, could be list 2, could be list 3. Wherever you put it, your responsibility to tell it what's there. Frequency list is always going to remain empty for us because we only use one list. We don't look at an abbreviated list with frequencies in the problem. We could, but my experience in trying to teach students that is that they don't remember when to use one variable statistics and then they try to use 2 variable statistics if they've got 2 lists out there. So it's just easier to do it into one. Okay, so if you're not using that, then when you pick one variable statistics, the only thing that you have to do, if you've got the 83, is you have to tell it exactly where to go look for the data of the problem. If you don't provide a director out here, a pointer that points to the list, it'll automatically always use list number 1, so you could get by, if you got the older 83, without putting the list in there, as long as you always put yourself in list number 1. But if you're one of the new users, you can't get by without putting a list up here. It's an automatic requirement. Won't even go off that line without that. The new people, after they put that in, they scroll down and hit calculate. It types up this on the screen very briefly and then immediately executes the operation. So then you didn't really get to see that, but those of you that type in by hand see it a little bit differently. So now the calculator dumps this information. Off of this screen, we are using mean value, and it's going to be a decimal value a lot of the time. They will tell us how many decimal places to keep if they want. We might sometimes have to know the sum of all the values, although that's not something that we generally deal with. The calculator gives us more than we need. We have no need for knowing what the sum of x squared values are. We have no need for knowing what to do, what we would get if we square all those values, unless we plan to do some things by hand. We get two choices for standard deviation. One, S of x, says this data was a sample. So the best I'm doing is estimating characteristics of a population. This one says, I got everybody. I have no one absent. I got all the values. There isn't any missing values out there, so I'm going to be 100% accurate, and we never touch S of x, or sigma of x, excuse me. If the sample is large, and this is only a sample of 12, if your sample is large, the larger your sample gets, the more these values begin to collapse upon one another. Because a larger sample gets to be more and more like the population. So they begin to approach one another. But for our purposes, it's all about S of x, and it's all about x bar. Those are the only ones we use. Yes?
How come we don't use that,
The sigma of x, because this class only deals with samples. We don't deal with populations. And it limits the potential mistakes that people can make. Believe me, if I could tell you a way to be able to remove the sigma of x, I would tell you to remove it, but I can't. So you have to be smart enough to recognize we never touch it. We're not going to do it. You want to talk about populations and samples and how they relate to one another, you can take the full-blown Math 241's class next semester, and you will see how those are used more elaborately. This is just an introduction. But really, by the time we get done with this introduction, you've got 4 of the first 5 chapters in that textbook taken care of. So you're good until almost maybe the week before midterm or something like that, okay? But you'll be doing a lot of other things out there. So for purposes of this class, we're not going to use sigma of x, we're going to use S of x. And they will tell you how many decimal places to keep. Oftentimes it's 2, sometimes it's 1, and it may be possible that your data set turns out to be a nice whole number, and you don't need that. So in this particular case, if we're going to go to 2 decimal places, then we would have 9.37. If you put in 9.36, it'll tell you you're wrong because you didn't round properly, but that's an easy fix. So read carefully what they want you to keep in the problem. Now that was not difficult at all. Before I go away from this screen, I want to show you what's going to happen if you make a mistake. If you make a mistake with the data input error, you're going to see the calculator said, you should have used this formula. And we are not doing that for the following reason. Let's just sketch out what you'd have to do. Let me explain to you what that's doing because there are some concept questions in there. First thing.